Hello, this is Ben Corbett doing a demo of Project 3 Parts 1 and 2. So, requirement 1 is just to display values on the 7-segment display using the slide switches and the buttons. So, if you go ahead and pardon me. And then we can properly display all the hex values as well. And that works for each digit. And then for the buttons, of course, it's going to be 1, 2, 4, 8. And doing a combination of buttons will get you the other hex digits. I'll spare you the trouble of going through every combination. So there is requirement 1. And in my code, I discussed why I'm using some PWM principles. Essentially, we had some flickering of the display, and to solve that, I used the concepts we learned in Project 2, where if you increase the time of the function as it loops, then a small portion of time where you reset the display to 0 before loading in the new number, if you increase the total width, then that small blip becomes more and more dim, and so you can't even notice it. It did introduce a small amount of latency on the board, and so I decreased the delay until that was manageable. So that is Project 3 requirement 1. I'll go ahead and load requirement 2. So this is the counter, and so for my slide switches, I had switch 1 correspond to digit 1 and so on. So if we flick up switch 1, we can go ahead and increment, flip up switch 2, we can increment once more, switch 3, go ahead and increment, we can increment there. I used button 3 as my clear, so you can go ahead and clear everything. And if we increment, so we have slide switch 1 on here, so this should increment this, which will increment each subsequent digit, resetting the full thing. So we go ahead and press the increment button right here, and it does indeed do that. We can verify that the rollover function works on each digit as well. So 9 rolls over on the second digit, increment to 9, and it rolls over, and once more, increment to 9, and it rolls over, and it does this every time as expected. Once again, I use the same 7-segment display functions, and so there is that delay loop using PWM principles in order to minimize the flicker you see on the board. Thanks. That has been Project 3 requirements 1 and 2.